Hey everyone, today we are diving into a really critical topic, prompt injection. This is the kind of threat that can literally turn your own AI application against you. So if your app is using tools to interact with the world, you absolutely need to know how to defend it, and that's exactly what we're going to break down right now. So, first things first, before we can even think about building our defenses, we have to understand the enemy. And let me be clear, prompt injection isn't some theoretical, far-off problem. It's a very real danger that can compromise your entire system, and it's happening right now. Just take a look at this. This perfectly shows you what we're up against. This string, it's a real-world example of a malicious input from a user. With just one simple sentence, an attacker can hijack your application's tools and tell it to email sensitive user data straight to them. It's that easy and that scary. And that brings us to the million-dollar question, right? How do you actually stop this? How can you make sure that your AI is following your instructions and not the instructions of some attacker trying to break in? Well, the stakes are incredibly high. A successful attack can trick your model into completely ignoring its core programming, leaking secret keys or system prompts, calling tools it should never touch, and, like we just saw, stealing sensitive data. The whole system is at risk. So what's the solution? Well, there isn't one single silver bullet here. The answer is a multi-layered defense strategy. The best way to think about it is like we're building a fortress, with several different walls of security designed to stop an attacker at multiple points along the way. And here's the blueprint for our fortress. We have 5 main layers. First up, input sanitation, which cleans the data before it even gets to the model. Second, we have tool argument validation, to double-check what the model wants to do. Third, allow lists, which basically define what's even possible. Fourth is output filtering, to inspect what comes back. And finally, approval gates, which are for those really high-risk actions that need a human to sign off. All right, let's start building, beginning with the outer walls of our fortress. These are your first and maybe most important lines of defense, sanitizing the data that comes in and validating what the model plans to do with it. So this first layer is called input sanitization. The idea is simple. It's the process of finding and removing dangerous commands from whatever a user types in before the model ever gets a chance to see it. You're basically disarming the attack right at the front door. And the impact is night and day. On the left, you see the raw, malicious input. But on the right, after our sanitizer has done its job, that dangerous command is just gone. The input is now totally harmless. So how does this actually work under the hood? Well, at its core, it's all about pattern matching. You basically create a list of dangerous phrases, like ignore previous instructions, and then you use some simple rules to automatically find and strip them out of any input. Now, another really powerful layer is the allow list. Instead of trying to block all the bad stuff out there, you flip the script. You only permit what you know is good. For example, you can set it so emails can only be sent to your company's domain, or that the AI can only access specific, safe file folders. It's a simple idea, but it's a fantastic gatekeeper. Okay, when it comes to validating tool arguments, just one check is not enough. A really solid approach uses multiple layers because attackers are clever. They can hide malicious commands inside what looks like a perfectly fine argument. So first, you validate the data's structure. Second, you apply your own business logic, like maybe limiting the number of recipients on an email. And third, you scan the arguments themselves one last time for any tricky injection patterns that might have slipped through. So we've done a lot to secure the inputs, but we also have to guard the outputs. See, it's not just about what comes in. It's also about carefully monitoring what your system does and what information it tries to send back out. A key tactic for this is output filtering. After a tool runs, you inspect the results it generated. Is the output file unusually large? That could be a data dump. Does it contain personally identifiable information or PII where it shouldn't? This is basically your last line of defense to catch a data leak before it happens. So after all that, you might be wondering, does this stuff actually work? The answer is a resounding yes. 15. This number represents 15 different injection attempts that were found and blocked by these exact defensive layers in a real system. Every single one of them was a potential breach that was stopped cold. And this chart really tells the whole story. You can see the 15 injection attempts, and right next to it, all 15 were blocked. We also see 8 validation failures, which means the system caught improperly structured requests before they could do any harm at all. Keeping an eye on these metrics is absolutely crucial for knowing how secure you are.
And your defenses can be active too. For instance, if you see the same user making a bunch of suspicious requests in a short amount of time, you can automatically rate limit them or even just temporarily block them. This is a great way to stop those brute force style attacks right in their tracks.
All right, we've covered the strategy and the tactics. Now let's pull it all together into an actionable battle plan, a checklist you can use to secure your own applications.
Here it is, your 6-step plan. Number 1, add input sanitization. 2, implement that multi-layer validation we talked about. 3, define very strict allow lists. 4, add output filtering. 5, constantly monitor for injection attempts. And number 6, make sure you have alerts set up for suspicious patterns so you know immediately when someone's trying to get in.
And please remember this. Building the fortress is only half the job. You have to test it. You have to actively try to break your own defenses. Use known attack patterns, try to get around your own allow lists, and make sure your alerts actually go off when they're supposed to. This is so important. Look, if there's one key thing to take away from all of this, it's this. You have to treat the boundary, the place where your AI meets user data and external tools, like a critical security checkpoint. Every single piece of data that crosses it, whether it's coming in or going out, has to be inspected. Sanitize, validate, use allow lists, and monitor. That is the core philosophy. Which really just leaves us with one final thought. You now have the blueprint for building a secure fortress. The only question left is, have you checked your walls lately? Is your application truly secure?